Okay, there we go. How's that? Come on, screen. There. Right, I'm doing 8F still. Question 5B. Chose 5B. It looked a bit more interesting. So the binomial that we're expanding is x minus 3 on x squared, all to the power of 9. The question wants to know what's the constant term, right? So if I was to expand this out, I would get 10 different terms. Somewhere in the middle, there would be a term that was just a number, right? A constant. Now that means, there's no x. It's just a number. How's that going to happen, right? Well, that's going to happen if you had x to the power of 0, because x to the power of 0 equals 1. Okay? So somewhere in this expansion, I go through, expand it, 10 terms, and x to the power of 0 pops up, right? As opposed to, maybe we're more used to something like this. Now we expand, I don't know. Let's keep it easy. X plus 2 squared, where does our constant term come in there? It's the last term, right? So you get x squared plus 4x plus 4. There's the constant term, right? If I'm using the general term formula to find that, that's the third term, right? So my r is 2 to get that third term. Right? So I'd be doing, and my n's 2, I'd be doing 2 choose 2, which is 1. Only one way to choose two things out of two things. Then x to the power of n minus r, that's 2 minus 2, right? So there's your x to the 0 in the formula, right? And then of course you've got the 2 to the power of r, right? So this is giving us that 4, and I have an x to the power of 0, right? In something like this one, that x to the power of 0 doesn't necessarily, in fact I'm certain that it won't be the last term like it was in that simpler expansion, right? Because when I get to the last term, I'm doing 3 on x squared to the power of 9, right? I'm going to have 3 to the power of 9 on x to the power of 18. Right? That won't be a constant term. I'll have to find it, okay? But we start out as you would expect, hopefully, using the general term formula, because that's what we're doing in this section. And we know what the n is, right? So we can say we've got 9 choose r instead of n choose r. Our first term is an x, and that will be to the power of n minus r. I don't know why I'm writing n, because I know what n is. It's 9. I'm going to change that, sorry. 9 minus r. Then I've got my second term. I'll put this in brackets because I want to keep that negative, right? Maybe. Probably. Okay, so I've got minus 3 on x squared. That's how I'm writing my second term. And that will be to the power of r. Right? So I can see that x to the power of 0 is going to have to come from these two bits here. Right? I can forget the 9 choose r. That's just some number. Right? I'll come back to that later. So I could maybe say, therefore, x to the power of 9 minus r multiplied by minus 3 on x squared to the power of r has to give me something. All right, it has to be equivalent to x to the 0. That's probably not the right notation. Let's to be mathematically correct, I'll say, look, it's got to be some number times an x to the 0. That's what I want. Right? If we're going to have a constant term. Okay? Now, you might choose to ignore this 3, but I think I'll keep it there. I'm going to work with this and think, what would my r value have to be to get a 0 x power, right? So maybe another therefore. X 9 minus r times minus 3 to the power of r, all to the power of r, and x to the power of 2r has to be giving me something x to the 0. I'm just using k to show that there is some number there, right, from the minus 3. But really I'm ignoring that. I'm just interested in the x's. Yeah? So I'm going to zero in on that for a minute. I'm going to think, maybe consider x to the 9 minus r divided by x to the 2r. How do I make this equal 0? Well, now can you see that? I've got x to the power of 9 minus r. That's going to be multiplied by this, and then it's going to be divided by x to the 2r. Right? I'm just considering my x terms. I'm thinking, all right, I've got x to the power of 9 minus r divided by x to the 2r. What is that? Right? Well, that is x to the power of 9 minus 3r. Okay? Oh, my screen keeps blanking. Now I'm using index laws there. I'm saying we've got the same base, x, but different powers, and we're dividing. What's the index law? We minus the powers. So I've done 9 minus r minus 2r. Right? 9 minus r minus 2r. You might want to think about that. Just the powers. 9 minus r minus 2r. Can you see that it's 9 minus 3r? Right. Good. Excuse me. I'm going to make some room over here. Right. So, I could say maybe therefore x to the 9 minus 3r has to equal x to the power of 0. We can equate these powers. What r is going to give us x to the power of 0? It has to be a 3, doesn't it? Yeah. 9 minus 3r has to be giving me a 0. I could say therefore 9 minus 3r equals 0, but I don't really need to. 3. I can see it. R has to be 3. 3r has to equal 9. R has to be 3. Okay? So I might want to just jump straight to saying that, but don't really need this working out. I can see it. Therefore, R equals 3. Okay, now if R equals 3, I can now put it back in. It's going to be the 4th term. I could say, okay, now let's go back to the original binomial expansion and think, all right, what is this term? So R is 3. R plus 1 term, this is the 4th term, right? I'll have 9 choose 3. I'll have x to the power of 9 minus 3, that's x to the 6, right? Then I'm going to have minus 3 on x squared to the power of 3, right? All multiplied by minus 3 on x squared to the power of 3. Can you see that you're going to get an x to the power of 0 here? Because what's going to happen is you've got x to the power of 6, right? Now you've got this x squared to the power of 3. 2 times 3 is 6. So you're going to have x6 divided by another x to the 6. 6 minus 6 equals 0. You're going to get an x to the 0 there, and you'll just be left with a constant term, a number. Right? You can work out what the number is. Should we do that? Find the constant term. Yeah, okay, fine. Right. So the constant's going to be coming from the fourth term. I almost want to just do this bit here, but we'll do everything. The fourth term. Okay, 9 choose 3. Calculator time. I don't know what it is. So I'm going to say, there's my calculator. Math. Prob. N choose R. 9 choose 3. The number is, that way, 84. Okay? 84 times x to the 6 times minus 3 cubed, right, is minus 27. And x squared cubed is x to the 6. Right. These can be cancelled out here. And we're left with 84 times minus 27. So back to the calculator. 84 times minus 27. There it is. Oh, I think the lighting's a bit odd in this room. 2268. So therefore, term 4, the constant term was minus 2,268. All right, thanks.